finding the whole. So what is finding the whole? Well, it has a lot to do with fractions, parts of a whole. Now, when we say the whole, we're referring to all, everything, the total amount or the total number of something. It can be any item, it can be people. For instance, here I have 6 marbles. So since the total number of marbles is 6, 6 would be the whole. The whole can also represent your allowance. For instance, let's say you receive $10 at the end of the week. That $10 would represent the whole because it's all of the money that you received. In this example, we have a class of 7 students. There are 7 students in the entire class. So 7 would represent the whole because it's the total number of students in the class. So the whole refers to the total amount or the total number of something. Now, there are different ways that we can represent the whole. Here, I have represented the whole as a percentage, 100%. Now, if you have 100% of something, that means you have all of it. So 100% would represent the whole. I have drawn a diagram. So here you see I have divided the circle into 8 equal parts, and each of the parts is shaded. So that would be 8, 8. So 8 out of 8 parts is shaded. So that's the entire shape. So that's also the whole. I have used a fraction, 7 out of 7 parts. That's the entire thing being shaded. Now the whole can also be any number. 1. Maybe I have 1 cookie. Maybe I have 2, 4, 8. Whatever represents all the marbles you have, all the cookies you have, that number represents the whole. In this example, we see that each student is 1/7, represents 1/7 of the class. Now let's look at the fraction that would represent all the boys in the class. Could you tell me what single fraction we can use to represent all the boys? Well, there are 4 boys, and we see here each one is 1/7 of the class. 1/7, 1/7, 1/7, 1/7. How many parts is that? That's 4 parts out of 7. So we can say that the fraction representing the boys is 4/7. Now, if you look to your right, you will see that each girl is also 1/7 of the students in the class. 1/7, 1/7, 1/7. And likewise, we can also represent the fraction that represents the girls can also be called 3/7, 3 out of 7 or 3 out of 7 students. Now, we know that we can use a fraction to represent all of the boys. We can also use a fraction to represent all of the girls. So the boys' fraction is 4/7, and the girls' fraction is 3/7. But is there a fraction that we can use to represent all 7 students? Think about it. Yes, we have a fraction that represents all the students, girls and boys, and that's 7/7. Now, if you look at the numerators for the boys and girls, you will see 4 plus 3 gives us 7. The total number of students, the whole, is 7/7, 7 students. So the whole, anytime you hear the word whole, we are talking about all. The total amount of something, the total number of something, right? Now here, we see that we can represent different parts of the whole as well. In this instance, we have boys and girls being represented by different fractions. We can also represent the various parts of the whole differently. Let me explain. So let's observe what is taking place here. Here we have the boys fraction, which is 4/7, because there are 4 boys. 4 out of 7 students represents the boys. I can use a common fraction by putting 4/7, and I can also use a bar model. So we see here that I have drawn a figure with 7 equal parts, 1, 2, 3, 4, 5, 6, 7. Now I have shaded 4 out of 7 parts since there are 4 boys. So 4 out of the 7 students are boys. So I've shaded 4 parts out of the whole. Likewise, when we look at the girls bar model, I have shaded 3 parts because 3 out of 7 students represents the girls. Now we also look at the bar model that represents all the students. I've shaded them all. 1, 2, 3, 4, 5, 6, 7. So we can represent the various parts of the whole in different ways. Now, what I've done here is I've mixed up the various ways that we can represent the whole and the parts that make up the whole. So I have common fractions, I have the numbers, and I have the bar models, but they're all mixed up. We can organize this into 3 columns. Here I have a column that represents the boys, a column that represents the girls, and a column that represents all the students. But as you can see, the information is still mixed up. So let's see if we can put the information beneath the correct column. So let's start with the bar models, the diagrams. So we have one here, and one here. Let's start with the first one here. Now, this bar model has 7 equal parts and they are all shaded. 7 out of 7 of them are shaded. So that would represent all the students. So we have to put it under the correct column. So let's put it over here under the column that represents all the students. So let's move on to this diagram. So here there are 7 equal parts, but only 3 of them are shaded. 3 parts are shaded. So that's 3 out of 7. Now, if I remember correctly, there were 3 girls. There were 3 girls. Therefore, this has to be placed under the column that represents the girls. And finally, of course, the last diagram would represent the boys because there are 4 parts shaded out of 7. And there were 4 boys. There were 4 boys in the class. So next, we're going to move on to the fractions, the common fractions. So there are 3 of them. Let's start with 4/7. 4 out of 7. Now, I can look at my diagram and see that 4 out of 7 students represented the boys. So I know that that has to be placed under the column that represents the boys. Now, you see I shifted 7 out of 7 into the column that represents all the students because 7 out of 7, that's all, that's the whole. That fraction represents the whole. Now, we're left with the numbers, 3, 4, and 7. Now, we know that there were 4 boys, so the 4 would be placed under that column. There were 3 girls, and we know there were 7 students in all. So here we have placed each diagram, each item under the correct column. So you may be wondering, what's the point of this? It's important for you to remember that we can represent the parts of a whole differently. We can choose to draw a diagram. We can write a common fraction, or we can simply use a number. They all represent the same thing. So for instance, the number 4 represents the boys because there are 4 boys in the class. 4 sevens represents the boys as well. 4 out of 7. Likewise, our diagram, 4 parts out of 7 shaded. 4 parts out of 7 are shaded. That also represents the boys. So always remember, we can represent the parts of a whole in different ways. So let's practice. Stephen has some marbles which are shown below. Draw 4 columns and show the various ways that we can represent the number of marbles that Stephen has. Now, in our previous example, we had a total of 7 students in the class. 4 of them were boys and 3 of them were girls. We drew 3 columns, one to represent the boys, one to represent the girls, and the last one represented all students. So you need to ask yourself some questions. What's the total number of marbles? How many different colors are there? How many columns would you need? That was stated there, you'll need 4. What information would you put in those columns? Would you be using bar models or diagrams? Would you be using numbers? Could you use a common fraction? So you ask yourself these questions. You can go back to the video, come back to the video to help you. So try this for me and let me know how you get along in the comments below.